Hello, welcome to the live session on COMSOL Multiphysics. In this session, we'll be talking about COMSOL Multiphysics, introductory COMSOL Multiphysics. And if you have any query, then you can go ahead with your questions. So I'll be waiting for your queries. So if you have any questions related to COMSOL, you can ask me in the comment box. Initially, I'll start with the brief introduction to COMSOL Multiphysics. And then I had a few queries from a few people that I'll be sorting out. There is one query like, is it possible to reflect or bounce up spherical object from the wall in FSI module? Okay, so I had this question in the last live session also. So I'll tell you the logic. Basically, in fluid structure interaction, remeshing happens in every step. So what we do a simple geometry. Suppose a spherical object that is moving in a channel where the channel is filled with fluid. So every moment it drifts, COMSOL multiphysics regenerates the mesh, and thereby in every time step regeneration of mesh takes place, and that is why when the object reaches to the boundary wall, it collides with the boundary wall, then remeshing becomes an issue because that bouncing physics is not defined in fluid structure interaction. In fluid structure interaction, if you see, there are two physics. One is fluid flow, and the other is solid structure or solid mechanics physics. So in those two physics, we have not defined this bouncing phenomenon, and that is why it is difficult to do. However, there is another module called FPT where there is option of bouncing wall. In the boundary condition itself, you can get this option, and there are few pros and cons of FPT as well as fluid structure interaction. In FPT, you can have this bouncing wall, while in FPT you cannot have many options which FSI offers, and that is why it depends on your actual problem. which physics you will be moving ahead with. You can ask me if you still have some doubt. Okay, meanwhile, I'll be proceeding with a brief introduction to COMSOL. So I'll show you the COMSOL interface. So this is the interface. This is the software. So in this software, we do several computational problems, starting from fluid flow, semiconductor module, heat transfer, mass transfer, solid mechanics. Sometimes we do chemical reactions. There are mathematical modules. There are optics. In optics, you have both ray optics and wave optics, and there are other physics as well. So it depends which area you are working on. So based on that, you have to choose an appropriate model. So I'll show the available model in COMSOL. So if I click on model wizard, then I choose any of the options you can see here. For the time being, I'm explaining the options available in COMSOL. That means the physics. So I'm not going into a particular model or model development, that I will come later on. So those are the physics available. You can see broadly it is classified into AC/DC, that is alternating current and direct current. In AC/DC there will be several modules. If you see, there are electric fields and currents, magnetic field with no current, electromagnetic fields, electromagnetic heating, electromagnetics and mechanics, particle tracing that I was actually talking about. That is one of the important thing, because suppose the particle, a charged particle is moving in a electric field or magnetic field. So in that case, if we want to solve something where a particle is there, it may be charged and that is placed in an in an electric field, and we want to model this particular phenomenon. In that case, this particle tracing module along with electric fields are used. Then you have acoustics. This is one of the very important physics that is available in COMSOL. So you can do pressure acoustics. Suppose you have to simply model a speaker. So there is an inbuilt model in COMSOL that mimics a speaker. How does a speaker work? That model is there. Suppose you are doing some acoustic related research problem, then those are the things available. So you can see pressure acoustics, elastic waves, uh, and thermo viscous acoustics. So this is another important area of physics where people do many work. So those things are available. You can see ultrasound is available. Now I'm coming to another classification, that is chemical species transport. This particular thing is important for people who are in from chemistry, chemical engineering, mechanical engineering, or interdisciplinary. So what are the things we can do in chemical species transport? You can see there are many options. If I read it out, that is transport of diluted species. In transport of diluted species, what we do diffusion, convection related problems, and this is diluted. That means millimolar to micromolar concentration of solid if you have, and if you want to model the same, then you take this. Another option is the reaction engineering. Suppose a reaction is taking place, a product is forming, and that is getting diffused inside a fluid medium. So this kind of problem we do with reaction engineering, reaction kinetics. Then we have Nernst-Planck Poisson equation. This is very much important if you are working with electrical double layer. So electrical double layer is suppose you have a charged surface, you dip the surface inside an electrolyte and it forms an electrical double layer. That means redistribution of cations and anions near the charged surface, depending upon the positive or negative nature of the surface. The redistribution happens and it forms an EDL, that is electrical double layer. There are such kind of uh, other kinds of physics available. So yeah, it depends on which area you are working on. So you should have an appropriate knowledge. If you want to model a particular phenomenon, then which area of COMSOL multiphysics, which module of COMSOL multiphysics you should be focusing on. And for the same, I am here to discuss with you. I will be coming live frequently in order to discuss some of the research problems or other design related problems. We have electrochemistry in COMSOL. We can, from the terminology itself, we can understand, we can do extensive electrochemistry, whether it is cyclic voltammetry, EIS, it is something related to Nernst equation, some electrokinetics phenomenon. Those things can be modeled. We have fluid flow. I have already talked about fluid flow. We have heat transfer. We have optics. So I was talking about optics, and you can see both the optics are available, ray optics and wave optics. So what we'll be doing, we'll be taking one physics every week, and we'll be focusing on it, and we'll try to do most of the things in order to do some problem with that particular physics. So now I'll be taking questions if you have. Another question I can see, how to calculate the volume of a portion of solid that is above a certain temperature in COMSOL. How to calculate the volume of a portion of this? Okay. I guess this is not a problem which relates COMSOL directly, but this is a problem which can be done from the data analysis. Suppose you have a data, I mean, you are working with temperature profile. You have a temperature profile, so you will be having a contour plot, and contour plot related data you can extract from COMSOL. So whenever there is a plot, so in a 2D plot, you will have a 2D surface. If you right click on the 2D surface, you will be getting data to export to to your system. So you export the data. You will have the data for the entire contour. Then with that data, you can do the post processing or whichever you require. Another question I can see, how to select extracellular matrix in material. Yeah, extracellular matrix like that way you cannot define in COMSOL. However, one thing you can certainly do, if you know the rheology of this extracellular matrix, how does it behave? If you have some literature from which you can relate the rheology of the extracellular matrix, then in COMSOL you have option of non-Newtonian fluid. You can model your problem with the rheology you have. So like that way, from the material, from changing the material property, you have to do this. Another question, how to select the pressure at inlet for microfluidic platform. This is very simple. If you choose, I'll show these things with COMSOL. Meanwhile, I'll take another question. Is it possible to define particle shape in FPT module? Uh, for the time being, I cannot tell because I forgot, but I'll look into it. Maybe in the next live session you appear, I'll be giving the answer of your query. You can also check APT whether this option is available or not. Material melts and vaporizes and gets removed. How to do this using deformed geometry? See, when you talk about material, there are two things, whether it is solid or liquid. If it is a liquid, then simple deformation with the help of fluid flow you have to do, because in COMSOL you have fluid flow, you have single phase flow, you have multi phase flow. Now, if both the things are liquid, then what you need to do, you need to define the properties of the liquids, maybe two phase, three phase. Then you simulate your problem based on the pressure or atmospheric condition. That means the boundary conditions. It will automatically take. But if the material is solid, then you can go with this fluid structure interaction. You can select the solid geometry and you can define the property. That can be done. If it melts and vaporizes, yeah, there is one. If you look, there is one module in model inbuilt model in COMSOL, that is evaporation of some milk or tea. Some model is there, evaporation of water in a cup. If you search on internet, you'll be getting. In that case, they have shown how to tackle the phase change in COMSOL. But I will suggest that doing a model with phase change is not so easy. It will be difficult because you need to know this saturation pressure, atmospheric condition, everything you need to know in order to do this. However, this is not impossible. It can be done using COMSOL. So you have to look into those models in order to start this kind of problem. I tried, but it seems that you can define the particle size. Yeah, particle size can be defined. That is for sure. But you are talking about shape. I am not aware of shape. And in every version, they are changing. They are bringing out new options. So I have to check once again. You can share your exact research problem in my email ID. Then I can give you some suggestions. I'll be happy to give some of the suggestions. How to do integration in COMSOL? Let us go with the model. I'll tell few of the things. So I simply take laminar flow that I took in the last week also. I'm doing this just to tell few of the queries people many times have. Yeah, there was one question like how to put pressure in microfluidic channel. So suppose I'm doing a fluid flow simulation in COMSOL multiphysics and the platform would be a microfluidic channel. Then what I can do is, initially as it is a microfluidic channel, let me choose micrometer option from this setting window. Okay, the people who are new, I'll just explain briefly the console interface. So there are three sub windows. This is called model builder section. This is settings section, and this is your graphics section. So whatever we do, the results, plotting, etc., will come in this graphics section. We can give inputs from this section, and this is the model building section. There are several parts. Like I always tell, initial part is making the geometry. So in any CFD simulation software or this kind of software, we have options for geometry. Then materials. This is obvious. Today only there was one question like how to define extracellular matrix. So if you can see, if I right click on it, there are options. Add material from library. So there is one inbuilt library. Somebody has noted down the properties of the materials and listed it as a particular material. When we choose water, suppose I choose water, I write water and click on search. So this is water liquid. So whenever I choose it, what does it mean with respect to computational aspects? This is basically a host of parametric values. or you can say property values like thermal conductivity. We have heat capacity, coefficient of thermal expansion. So water in terms of computation means host of physical parameters and their values or function. Why am I calling it function? Because sometimes a particular property may depend on temperature, like viscosity depends on temperature. It is not a constant. So some relation with respect to temperature is listed here. So likewise, there are many inbuilt materials available. But if I want to model extracellular matrix, probably this material will not be available in this library. So you have to know all the properties. You can put those properties and you can do your simulation. Okay, now I am coming to this microfluidic channel. So this is a 2D geometry. Let us take one rectangular section. Say the height is 10 micron and the width is not 100, say 50 micron. I click on build object. So this is the microfluidic channel. Now simply what we need to do, we need to put water inside this microfluidic channel. So when this is shown in blue, it is selected. If it is not, we have to select it. Now the question was how to put pressure. Simply right click on it, put an inlet condition. So this is the inlet. I click on it. Change this from velocity to pressure. Suppose I keep some gauge pressure of 50 pascal here. So this is how you can put pressure condition. This could be a constant pressure condition. This could be a profile of pressure. So it depends on your problem. Whatever profile you have, you can put it here. You can put a function also, and the functions can be defined in this section. There is one option called definitions. If I right click on it, you will be getting variables. So you can define your variables here. If you search on internet, you will be getting how to define a variable. So this is how inlet condition is defined. I can define outlet condition as well. Let's say this is the outlet. So let us keep pressure equal to 0 at the outlet. Fluid properties, if I click on it, by default it is taking from the material because we have defined the material. You mesh it, simple meshing. Now go to time dependent and you solve it. So this is the simple thing you can do. Okay, there are a few questions I missed. Okay, some problem of from a metal sheet. I guess somebody is hitting the material or somehow it is getting heated and it melts. So yeah, this kind of problem will be a bit difficult to model, but you can look for available options. There are very few things available in COMSOL related to phase transition. Maybe in the next live session, I can tell more about this. Oh, how to do integration in COMSOL? I did not understand exact problem, but what I can tell you, this is a post processing section or results. There will be few options available in build, like we are solving fluid flow, so velocity and pressure profile is automatically coming. Now what there is one option derived values. If I right click on it, you can see integration option is available. Suppose I want to do a surface integration. So I click on it, I choose the surface. Now what I mean, surface integration of what? For that I go to, yeah, I click here, I go to laminar flow. Let me choose some property. Suppose I choose pressure. I want to do a surface integration of pressure. I click on evaluate. Yeah, you can see that surface integration. Yeah, yeah. With respect to time, surface integration is calculated. At different time, surface integration of pressure is calculated. Now, if somebody asks me like how to do line integration, so let me choose line integration. Let us take a line, say this line. Again, a property. Let us choose velocity for this for the time being. Yeah, so velocity is a vector, so you have three components. Let us choose x component because fluid is flowing in the x direction. Then click on evaluate. So yeah, this is the velocity field and this is the line average. That means each point will show different velocity. What am I doing? I am taking line average along the outlet section. Few more comments are there. My research problem is similar to this. Okay, I'll go through maybe in the next live session. Okay, difference between parameter and variable. It's very simple. Suppose I define viscosity as 0.01 Pascal second. So that is a parameter. If I define it as a function like AT plus BT square, so that is a variable. When it is a function of some other independent variables, then we call it a variable in COMSOL. Okay, that is nice. There is another answer to Deepti Ranjan. There is an example of welding available in COMSOL library. So you can go through that. That might help you. Integration, I have talked about somewhat. How to add concentration. Concentration means which problem you are targeting. We can add concentration. For that, we have to use transport species equation. If you elaborate more, which kind of concentration you are talking about, then maybe I can answer your question. So we'll be continuing this live session maybe every week. So I started with COMSOL and then I'll be moving to other things like coding and related problems that we use in research. So we'll be doing live sessions every week or at least bi-weekly. So if you have any query, you have my email ID. You can write to me. So once I gather a few queries, I will be coming on live and we'll discuss with all of you. And that will be very good to have a discussion because this kind of discussion will help many people. In deformed geometry module, what is that? Elastic or Laplace option under smoothing section. I have not gone through this, but if you go to the equation, there is one option I'll show. Everywhere you go, something is written here. Suppose I choose one, some equations will be written. If I choose inlet, in inlet also some information will be given which kind of equations this boundary condition is taking. So you'll be dealing with your field of area. So maybe everybody will not be able to understand your equation. But in COMSOL, all the things are defined here. Wherever you go, suppose I go to laminar flow in the main section, in equation you see the equations are given, which basically COMSOL is solving. That is momentum equation and continuity equation. Similarly, in all the sections, wherever you go, there will be information, and if you read those information carefully, and if you understand this, that will solve your query. Okay, so this is nice to see that people are interacting. So please put on comments like if you need this kind of discussion, not only related to COMSOL, but also related to other research stuff, then we'll be happy to, yeah, we'll be happy to bring this kind of sessions live. If anybody else having any more queries, so again I'm telling, keep writing to me. Once I have a few queries, I'll be coming live and we'll be discussing with all of you. Sometimes we'll be having session on basic introduction to the software modeling, any kind of CFD related problem, how to tackle, how to do simple coding. So all those things will be covering one by one. Please keep writing to me because I'm trying to make a community online where we can talk over YouTube or some other platform. And currently I am here at Indian Institute of Technology, Gandhinagar. I am doing a kind of postdoc here. So if anybody wants to interact with me regarding any research problem, you may think that a collaboration or kind of discussion will be helpful. Then apart from COMSOL also you can write to me. Yes, Anirudh. Yeah, we'll be taking this initiative. So please write back to me or also share this view with your circle, with your peers, so that we can have this research community online. And through my YouTube channel, it will be great to have those discussions. Also, research collaborations, not only because all the things cannot be discussed over a public platform, so we can have individual discussion as well. And sometimes many people write to me, but I do not get time to make comments or reply to individual emails, and that is why I have taken this initiative. And that's why if you people keep writing to me, then only I'll be able to continue this thing. Another idea I have, which I want to share today, that in our research we use many instruments, and sometimes we do not know how to analyze those instruments. We use many softwares, we use many coding languages, but we do not know how to tackle a particular research problem with this particular tool. So we'll be focusing on those sections. We'll be individually talking about, say, visible spectrophotometry, Raman spectra, say AFM, say FESEM. In computational aspect, we'll be talking about COMSOL, ANSYS, maybe sometime MATLAB. So this kind of things will be continuing. And if anybody wants to contribute in this live session, then I can take that person online and we can have a joint discussion. This kind of things can be done. So I guess related to COMSOL today, there are no more queries. The last request to all of you is please share this initiative to your peers so that we can continue this stuff, this kind of stuff. So I thank you all once again. If there are no more queries from you, I'll be waiting for a minute or so and then I'll sign off for the day.